Good morning again. Still having my morning coffee. It ain't quite that hot out yet. It's getting there. But so why did I keep going back to the magnetar? What is the magnetar? Magnetar is a white dwarf spinning at extreme rates. We talk about it a lot in astrophysics because, well, it's a tiny city-sized mass with extreme gravity. I mean, extraordinary gravity. It crushes everything. And when we study it, we recognize the magnetic field that produces that extraordinary crushing force. And because we follow space-time, we separate that. And but it's not separated. It's the definition of what's going on. So as the mass rotates, that is a moving charge, because mass equals charge. That is a moving charge. It's trying to expand is what it's trying to do. It's trying to blow up. And the universe responds, the magnetic field responds by crushing it back, stopping the explosion. And in doing so, rotates it. And the more it tries to push out, the harder the field pushes back in, the faster it rotates. And it crushes it. And the more it crushes it, the faster it rotates. And it becomes obscene. Astrophysics marks it down as, in their equation, if you look at their equation, I sent that on the paperwork. It's in the equation that gravity is a result of the rotation and the mass and gravity and all that. But when you really study the equation, what it's telling you is the outward expansion of mass is counteracted by the inward crush. I call it a crush because of the size of the mass we're talking about. The inward crush of the electromagnetic field. So as mass tries to expand, the magnetic field responds with an equal force. And that is what we call magnetism. And it's also what we call gravity, but gravity we see as a neutral. We calculate for neutral bodies. We are neutral. So it works very different. We are not a positive or negative charge, which really doesn't mean anything, by the way. So positive, negative charge is you have two different fields. One is stronger than the other. One has more power than the other. That is your positive and negative. So the zap of electricity you see between one field and the other, like when you do a diode and an anode, what you're doing is you created a circuit, you cut a line in the middle of it, and you created a positive and a negative, a strong charge on one side and a very weak charge on the other side. So eventually the strong charge builds, and jumps to the other field and balances it out. That's what electricity is. It's a balancing force of two different fields. The universe is very, very simple. When you go to atomic size, it's the exact same thing. All right. The magnetic field stopping the atom from expanding. The crushing force, the thing that makes the atom rotate, the thing that creates the shell, the thing we call the electron, is actually the magnetic force. And the more mass that the atom has, the stronger the electron. All right, or the more electrons, however you want to word it. We studied the atom before we studied electromagnetism, which was backwards. Maxwell was working on the electromagnetic field. They shushed him up the moment he realized that mass equals charge. And he started redesigning the atom, saying that there was no such thing as a monopole. And they proved him wrong politically. It was a political ploy. It wasn't actually proving him wrong about anything. It's what we call, in argument style, it's what we call the straw man. You take somebody's argument and you break it down to a mimicry of what they were arguing, and then you fight against that mimicry, and you post that all over the web, and then all of a sudden you win politically because you destroyed him and his theory, but you didn't. You actually just destroyed a mimicry, a mockery of what Maxwell was saying. Years later comes Lorentz. He picks up where Maxwell left off, but he was actually following a little bit of that mockery because he was actually looking for the ether. Maxwell understood the magnetic field. That's what he was chasing. He was a mechanical realist. Lorentz was a mechanical realist too, but he was, when you first study magnetism, it really does look like a fluid or some kind of a flow that causes it. So it gets a little confusing. So he got stuck there, but he was measuring for magnetism. No matter what he was looking for, he was measuring magnetism. So his math is spot on. I mean, across the board, we as much as they laughed at Lorentz, they absorbed his math left and right. Time dilation and how things work in space and all that is all vital. And that's all Lorentz. And Lorentz used Maxwell. And all through general relativity is Maxwell. And a lot of the things that don't work have nothing to do with Maxwell and Lorentz. I'm just saying there's a connection there. And realizing that is what led me down the line that I went across. And it's been one heck of a summer, or a spring, I should say. It's been one heck of a spring. If you follow me back from early March, I started off with liquid gravity, and yeah, I ended up getting sick. I was very sick at the time, and I didn't even realize it. And I ended up on, I was blood poisoning, so my brain was just kind of like, but when I took care of the tooth infection, everything got better, and I got back on track, and quickly dismissed fluid gravity altogether. For obvious reasons, when you get into it, there's obvious reasons why fluid gravity does not work. We are definitely talking about a field interaction, but space-time doesn't work. You're literally trying to put space as a warping factor that has no reason for that space to warp, no reason for that space to cause gravity, no. Space is nothingness. So even if nothingness warps, it doesn't move anything. It doesn't change anything. You need mass to change or warp anything, to move anything, to alter anything. So even if mass changes space, you're not giving any kind of a contextual connection between the mass and other masses involved. You're giving geodesic lines, but you're not explaining how those lines interact. There's no interaction between mass in space-time. There's no explanation as to how it interacts. It just simply says it does, with no explanation. So you lose the understanding of how things work. Maxwell was studying how things work. Lorentz was picking up from there, but he, like I said, he was looking for the ether. But his math was spot on. He was calculating everything exactly the way it was happening. He was just looking for something that wasn't there, which was a fluid or an air. Or at least nothing I can comprehend, because, like I said, it has to be a field interaction. You start throwing fluid dynamics into it, and it screws everything up. But as a field interaction, where space is an empty void, minus whatever radiation and stuff like that is going in between, and understand that the magnetic field is everywhere, just in different gradients. The magnetic field is everywhere, but in different gradients. That's the important thing to keep in mind. There really is no such thing as empty space. All right?